All right, so context-free grammars, you want to say what you're allowed to do and what you're not, what sort of operations you can do and what operations you can't do. And this is my thinking myself. I decided that what you are able to do is you're able to do unions of languages, you're able to do concatenations, just like when you're doing regular expressions, you can do unions and concatenations. And there's this other thing you can do, which I'm calling spew and plop. All right? And I'll tell you in a second what spew and plop is. All right, so what is the definition of spew? It's to vomit, to ooze out, to come forth in a gush in a violent way. That's spew. And what's the definition of plop? Is to drop suddenly into water that goes bloop, plop, right? So let's see how we're going to do it. Suppose I had a grammar already that could do L1, and I have another grammar that can do L2. How do I get a grammar that can do the union of them? Well, I just do this. Here's the start state for the L1 language. This is the start state, start symbol for L1. This is the start symbol for L2. And so that's what we do. And watch, how do we see from S, what can I generate? Well, I could go from S to S1, and then from S1, I can generate anything in L1, right? Or I could go from S to S2 and generate anything in L2, right? Does everybody see how you just add this rule on top of your grammar that you had before, and you can do union? What about concatenation, right? So here's my new rule. S goes to an S1 followed by an S2, right? That means, what is an S? Well, an S is something from L1 followed by a something from L2, right? And how does the parse going? Well, S goes to S1 concatenated with S2, and then the S1 can give you anything from L1 versus the S2 gives you anything from L2. Does that make sense? Now, what's spew and plop? Suppose we have a rule like this. Well, what is an S? Well, an S could be an A followed by an S followed by a B. So what do we do with that rule? Well, you can keep spewing out. Here, I keep replacing the S by an AB. I keep replacing S by an ASB, and so then they spew out in this way, right? And then how do you stop? Well, you have to stop by having this is a non-terminal symbol. S is a non-terminal. We got to get rid of all non-terminal symbols. So you can have a rule, well, S goes to, say, the pound symbol, and that's where you plop the something in the middle, right? So here, this looks like, here's a complicated language, all right? So let's first figure out what this language means, right? It starts with a 0-1 string, and then it has so many A's followed by so many B's, followed by so many C's, followed by so many D's, and followed by a 0-1 string, right? But they're links. The number of A's can be any n, but then the number of D's has to be the same, right? We have to have the same number of A's and D's. And here, you can have as many B's as you want. I'm always going to, when you have just a letter like that, I'm going to assume M is greater or equal to 0. So I can have any number of B's, but the number of C's has to be the number of B's times 2 plus 3, right? So that's a language there. And I like to, you know how I like to give names to my states of my DFAs. I also want to give names to my non-terminals. So here's a non-terminal, and what do I want it to generate? I want it to generate anything from this language. All right, so how do we do that? Well, I have these various steps that I made up. Let's first step is to look for links and for concatenations. All right, so what is our link? This N is linked to that N. This M is linked to that M. So here, those are linked because they both BF the size N. Those are linked by the M, right? And then those guys, do they need to be linked? No, this can be any size and this can be any size, right? So they're not linked, but we kind of concatenate that on the end. And those extra 3, here we got, how many C's do we have? 2M plus 3. Well, those last 3 are kind of stuck in somehow. We got to figure out how to deal with those. And then this last bit here is concatenated on, right? So here I've broken up my language into these various pieces. And when I do that, then my next step is to give names to the parts, all right? So let's call this part an A, right? It's any string. What's an A? Is any string of zeros and ones. Well, this is also any string of zeros and ones, so we can give it the same name A. And let's call this big thing here a Q, right? So now we need some grammar rules. S goes to what? Well, it's just a concatenation. S goes to an A followed by a Q followed by an A, right? And here, when I have an A here and an A here, this A can generate any 0-1 string, and this A also generates a 0-1 string, but they don't have to be the same 0-1 string. All right, now, once we did that, we kind of recurse. We can then say, how do we do these other parts? Well, how do we get a grammar for this? This is just any 0-1 string. Well, I looked for links and concatenations. Well, that's a spew. The I here is we're spewing out characters, right? So we give names to the parts. Well, 0-1, let's just call that C for character, right? So what do? We spew out, what is an A? What is a string of 0-1s? Well, it's some character is 0-1, followed by an A, right? A string is a character followed by a string. So here, that's how it spews, right? It spews all those C's. And then we want to end it at some point. At some point we end. So how do we get rid of that capital A? We can plop the empty string, right? That just plops down. And now, see, what A is a series of C's concatenated together, right? All right, then we recurse. How do we build a grammar for C? Well, it's a union. We give names to the parts, right? What's a union? We just say, well, C is either a 0 or, I don't know if I've told you yet, this line up here means C goes to 0 or C goes to 1. Right? So here, what's a C? It's either a 0 or a 1. Right? And as I said, those are all chosen independently. So each of the C's independently gets to choose whether it wants to be a C or a 1. And that's how our A went to a 0-1 string. All right, now let's go back to this thing. How do we get a language for this? Well, we look for links and concatenations. Remember, those things are linked together. So how are we going to get those out? We got to spew them, right? We got to spew out A's and spew out D's, and we spew out all of those things. I guess the question is, which do we spew out first? Do we spew out AD's first or BC's first? And we always start from the outside working in, all right? So what is a Q? Well, it could start with an A and end with a D, right? Suppose our Q starts with an A and ends with a D, then what's between that A and D? Well, what's between them? Here I'm just saying we're going to spew those, and in the middle we're going to have that T there. All right, so what's our spew? Well, our Q What's our Q? Well, it could begin with an A and end with a D. And then what's inside? Well, it's still what's inside. If we make this an N minus 1 and an N minus 1, it's still a Q, right? So a Q is an A followed by a Q followed by a D, right? People kind of follow that? And if you see when we run the grammar, it spews out A's and D's, and it spews out them in the same number. We get the same number of A's and D's. All right? Now, what do we want to plop in the middle? Well, we said this thing was a T. Oh, but these three C's I didn't include in T, right? So maybe we'll plop them, right? So what do I plop in the middle? I plop this T thing, and I'm also going to plop the 3 C's, right? So those are characters. C's are character. Oh, no, oops. That C is different than a capital C that we did before. That was a little confusing. Never noticed that before. All right, so now we want to know, okay, this is great, but what's a T now? All right, so we recurse and say, what's a T? Well, we look for links, and those two things are linked together, right? So what we're going to do is what's a T? Well, it starts with the B, and for every B it starts with, it has to end with the CC. So a T is a B followed by a T followed by a CC, right? And then those can spew out. And then what do we plop in the very middle? We plop the empty string. People kind of get that example?
So I just have a question. So they are related, not based on they're related because they have the same variable. So like n matches n, and n matches 2m. And even though it's 2m plus 3, we can eliminate the 3 by putting like a fixed number of c's.
Yeah, by putting in those 3 c's. Yeah, exactly. Exactly. So what's the whole grammar? Right? The whole grammar is that, right? We just put all our pieces together. So a question I've asked on many tests is I give you something like this, and you have to give me a grammar like this. And I put it on so many tests that I worry about putting it on more tests because, you know, people have all those old tests available maybe. But all right, so here's another one, right? Here it's some number of A's, B's, C's, and D's, but what's linked, right? The number of A's and the number of C's need to be the same, right? The number of B's and the number of D's need to be the same. And so let's see how we're going to build a grammar for this, right? Well, we could spew those out, and we could plop in that. But then the number of B's won't necessarily equal the number of D's, right? People see that? If we spew out C's and we plop the B and we concatenate this guy on, there's no way of linking those two. People kind of see that?
Because we can't start from like the ends, like how you said before, and then go inside.
Yeah, you're right. We're not starting, if we start from the end, we're just doing this, but we're not managing to link the D and the B.
Why can't you spew all of them at the same time?
Numbers?
Well, if you skew AB, then it'll go AB, AB, AB. It won't have all the A's together.
Okay.
Right?
Yeah.
So, or we could, but that was a good idea. We could try to spew those and plop those, and then those aren't linked. So the point that we could try to formally prove this, but we don't want to. So we're just going to hand wave and say, if you got a pair of things that are linked, and here a pair of things that are linked, and those links cross over, then it can't be done by a context-free grammar. Right? Does that make sense? And the way you would prove it is by a really ugly pumping lemma that we are just not going to do. So here's another example. How do I get a block of A, B's, and C's, and I have each of them? I want any number of A's, but the same number of B's and the same number of C's, right? Then there are a lot of things that are linked here, and they all cross over. And so there's no context-free grammar for this. How about this one? Here's a language where I have any string of, here maybe those are characters, right? Any string of characters followed by the exact same string of characters, right? Do you think we can do this guy? No, right? Because the first character has to be linked to this being the same. This character and this character have to be the same. And this character and this character has to be the same. And look at those two linked things cross over. And so context-free grammar can't do it. But what about here? Here I have some string followed by the reverse of the same string, right? So it's like a palindrome.
Won't those still be linked?
Hmm?
Won't those still be linked? Like,
Yeah. Yeah, so now the first character is linked to the last character, and this character is linked to that character, right? So, but the difference is these links are not, they don't overlap each other, right? They're nested inside of each other, right? So now we can spew things out, right? What's our grammar? Here, an S is you spew out a 0 S0, so that spews out an S, or you spew out a 1. And, oh, do I not give it to you? I should have given you an example, right? You spew out 0, then you spew out 1. Yeah?
So as long as they don't overlap, you can do it?
Yeah.
That's how it works? Okay.
Yeah. Right, and you might say that that's restricted, but when we're doing Java, for example, this is a very common thing, right? We have a begin algorithm, we have an end algorithm, right? Those are kind of linked, right? Here we have a begin loop and end loop are linked. Here we have those brackets are linked, right? And they're not, they all are nested. So context-free grammars are really good at code like this. Does that make sense?